Assalamu alaikum, hope you're doing well. Welcome to the topic of ROS, which is the robot operating system, which is what we will be using in our lab. And indeed, it is one of the fast ways to build a robot, as even the website claims. There are actually several thousands of people around the globe who have been using ROS for implementation of different strategies on their robots. But not only that, they have also contributed to building functionalities. Like they have contributed with their solutions related to navigation, related to AI, related to deep learning, which we can also make use of so that we focus our efforts on the higher end of the spectrum. So we focus on solving problems that really matter, and we don't always reinvent the wheel with the problems that we are trying to solve. And we can implement this in hardware, the actual robots, or even software, because it gives some access to Gazebo, which is the platform that can simulate a robot as well. So how do we get started? That's the question that we should ask ourselves at this point. We will get started by understanding the package management, like the architecture for ROS. How is ROS dealing with its communication protocols? How is it dealing with its architecture? So we need to understand packages. What are packages in ROS? Each package is dealing with a specific robot's functionality. And each package is divided into several nodes. And every node is responsible for a single purpose only. So, for example, we have this control package. It can have several different nodes. What are the nodes that it can have? For example, there can be a node for controlling wheel motors. There can be a node which publishes the sensor data. And the entire package is the control package. And how is this important? How is this so useful for us? It is very useful for scalability, because, for example, you have been working on an autonomous vehicle, on an autonomous robot, and you have implemented all the navigation techniques, all the mapping techniques on the autonomous vehicle. Now, if you want to also work on an autonomous drone, it will be easy to scale up because you can reuse the navigation and mapping packages that you have already developed. So once you develop those packages can be reused for different types of robots for solving different problems. So this is an overview of why, like how ROS is dealing with packages. Each package has is dealing with a single robot's functionality, and each function has several nodes belonging to it, and each node is responsible for a single modular purpose. So this is what we have said related to the packages. So what is a workspace? A workspace is a folder which contains all our packages. But where are the packages over here? As you can see over here, the ROS workspace contains 4 folders. The last 3 folders are automatically generated, which is why we have auto over here. The source folder is what we will actually work on. We will add all our packages within our source folder. So every package will be in a source folder. But what will all the packages contain? All the packages will contain the nodes. And how will the nodes be written? They will be written in Python. So where will the nodes be, let's say, placed? They will be placed inside scripts. So this is the overview of how we will deal with the files. We do need the package.xml file also, which will be automatically generated. But whenever we are adding something related to import, we are adding some dependencies, they also need to be specified within the package.xml file. But all of this, you will get used to it once you are dealing with some examples. Now the question is, how do nodes communicate with each other? Nodes communicate with Actually, different communication protocols. One such protocol is that related to topics. So there is one node over here as an example in this animation, which is publishing some data to a topic. It is publishing, let's say, the speed of the robot's wheel. Let's say the speed of a wheel of a robot is being published to this topic. Now there are two nodes over here which are interested in gaining information about the speed of the robot's wheel. So they want to gain that information. They are subscribing to this topic to gain that information. So there is one node which is publishing to this topic, which is sending data, sending information on this topic, and there are two nodes which are, let's say, subscribing to this topic as an example. In reality, there can be multiple publishers to a topic, there can be multiple subscribers to a topic as well. So this is one of the communication protocols that we will make use of.